In today's lesson, we're going to be talking about congruency. To be congruent means that you have the exact same size and shape as another shape. So an example of that is these two shapes right here. I have square ABCD and square WXYZ. They both have all right angles for their angles inside, and they have a length of 3 on each of their outside things. So I can then write that ABCD is congruent, and this is the symbol that means congruent, not equal. This is what symbol you use to write congruent for. ABCD is congruent to WXYZ. So congruent means having the exact same size and shape as each other, and ABCD, WXYZ both have the same side lengths for all of their sides, and they have the same interior angle lengths, or measures rather. Now, there's another definition of congruency, and before we can talk about that, we need to remember our rigid transformations. So we have 3 rigid transformations. Those are sliding, flipping, and turning. And the way we talk about them more mathematically is to translate, which is sliding, to reflect, or reflection, which is flipping, and then also to rotate, a rotation, which is the same thing as turning. Let's take a look at 2 shapes over here. Now, I don't have a measure for these 2 shapes, but I can show that they're congruent by using a rigid motion to map one of these onto the other one. So if I take a cutout here that looks just like, or is the exact same size as congruent to ABC, if I can use a rigid transformation to move my first shape onto my next shape, that means that they're congruent. Well, I'm going to translate this shape ABC onto EDF. So that means that these are congruent, and I used translation. So I used translation to show that triangle ABC is congruent to triangle EDF. All right. Well, we had 2 other types of rigid transformations. Let's see how those look. I've now got triangles TQR and TSQ. Which rigid transformation can I use to show that these 2 triangles are congruent to one another? So I can use a reflection. If I take this triangle TQR and reflect it over that line that the 2 triangles are sharing, I see that they're actually completely congruent. So TQR is congruent to TSQ by reflection. All right, and there is one final type of rigid transformation that we know. That transformation is a rotation. If I take, let me make sure I'm placing this down right. If I take triangle RST and I rotate it around this point right here, I will be able to, let me keep turning this, map it directly on to, I said RST, onto UVT. So I just showed you that RST is congruent, that symbol for congruent, to UVT by rotation. And that's it. We can now come up with a different definition for congruency. Before, we had a definition saying that congruent means to have the same size and shape exactly. What can be a second definition that we can use to help define congruency? So a second definition that we have right here is congruent. Two objects are congruent if one can be mapped onto the other through a series of rigid transformations. That's it.